Alright, can somebody remind me how we graph y equals 2x minus 3 written?
You make the slope, right? You like solve for the slope and then make the dot.
Okay,
You go down 3. You go down 3.
okay, you start it down 3.
And then you make 2 over 1.
Okay, and then you go where?
You do
What's
2,
the sign?
no, 1 over 2 up.
2 up, 1 over, rise over run. So you go up 2 over 1, up 2 over 1. Then we drew a line, right?
Yeah.
Oh, some of us did anyway. You're supposed to draw a line.
Mr. Aaron, what's the assignment?
Secret.
Why?
Okay. Today we're not doing that. That's something from the past. Today what we're doing is graphing inequalities. Hold on, let me back up a second. What does this line have to do with this equation? How are they related to each other? Well,
The equation is telling you how to make a y.
well, kind of, but why? What does this have to do with that?
It's the equation you saw the graph.
The equation is related to the graph, yes. How are they related?
They're basically the same
And
thing.
it tells you the y-axis and the slope.
Yeah, okay, but why? What does this picture have to do with that, though?
I guess.
Okay, all these points on this line, not only the ones that I drew, but all these infinite number of points here have an x and a y coordinate, right? Like right there is 3, 3, an x and a y coordinate, right there. Even all these little decimal spots, these random decimal spots, they have an x and a y coordinate. All those x, y pairs are a solution for this equation. Okay, so this is a picture showing you all the answers that work in this equation. Does that kind of make sense?
Yeah.
So if I pick a random dot on there, on the line, there's going to be two coordinates, an x and a y, that if I plug them in over here, they're going to work. So it's a picture showing numbers is what it's supposed to do. A picture that shows numbers. Maybe I should pause for a second. We probably should have done a word problem like this. Let's say the population of
Flint City.
New York.
a little town doubles every year, and we'll let X be the years. Okay, the population of the town doubles every year. Okay, so after 1 year, there will be 2 people, right? So when X is 1, Y is 2. After 2 years, there will be 4 people. After 3 years, there will be 6 people. So 1, 2, 2, 4.
Oh, you said doubles every year.
Yeah, well, double. Yeah, I didn't do that right. It's double the number of years. That's how I set it up. If it doubles every year,
You could just say 2 more short.
it'd have to be y equals 2x minus 1. That's too complicated.
I don't get it.
Let me make it simpler. Let's say it, that would work. Okay, how many, let's say, 8th graders, how many kids are in your class right now?
Not a lot.
16. And, okay, yeah, it's a lot. Too many kids. How many girls are in your class? Let's try that. 7.
You could say half of it's 8.
Okay, let's say every year after this year you're going to gain 2 girls. So
That would be something.
that'd be a lot by the end, right? So right now you got 7, and every year after this you're going to get 2 more. So 2 times the number of years plus 7. So on this year, we'll call this year 0, you have 7 girls. That's still too many. I'm going to have to count by 2s. 2, 4, 6, 8. So you got 7 girls on year 0. After 1 year, you'll have 2 times 1 plus 7 is 9. So after the first year, it's gonna go up to 9. After the second year, it's gonna go up
11.
again. Yeah, you're gonna have 11. So that's way up here. I'm counting by 2, so it doesn't look right. Anyway, and I keep going, and it'll look like that. By your senior year, which would be like right here, you'll be up here. This line represents how many girls are in your class. Okay, if that was true. If that was true. So each dot, like, represents at this point in time, this is how many kids we have. So these dots represent two numbers, like the number of years and the number of girls, that if we plug them in right here, that will work in the equation. Alright, anyways. Got way off track there. So we're not graphing lines today. What we're graphing is inequalities. Okay, so it's going to look more like that. Y is greater than or equal to 2x minus 3. So if that was the inequality, did you guys know this was called greater than?
Yeah.
Can you differentiate between greater than and less than?
Less than looks like an L.
Okay, less than looks more like an L. Greater than is the other one. Greater than, less than. That's important. Okay, if it's y is greater than, then what I'm going to do is shade. I'm still going to draw the same line. I'm going to shade everywhere above the line.
Oh, we're doing this.
This thing.
Okay, why did I shade?
In any of that spot
Because-
you shaded in.
Right, any point in this region, like if I choose a random dot right here, that's like -2, 2. If I plug that in for my x and y, it should work. So if I plug in -2, 2 times -2 is -4, minus 3 is -7, is 2 greater than or equal to -7? Yes. So any random dot in this shaded region is going to be a solution
Who came up with all this stuff?
to this. I don't know. So the points on the line are still part of my answer, by the way. Okay, the points on this line are still part of my answer because the line is basically y equals 2x minus 3. However, if I change my inequality to this, what did I change?
You have to open circles.
Not quite. I got rid of the or equals to. In this case, the line would not be part of the answer. So if I was to graph y is greater than 2x minus 3, I would still start the same way, but when I drew my line, I would have to make it a dashed line. What do you think the dashed line means?
It's not.
Not included in the answer. Kind of like when we did the graphing, like greater than 4, we put an open circle like that.
Does that mean you still shade?
You still shade, all this is still part of the answer. But if it's not equals to, then the line is not part of the answer and we put a dotted line, dashed line. is what they call it.
But you still like make your line by starting at.
Did everything the same,
Are
but
we ever gonna do like
instead of drawing a solid line, we just drew a
Are we
dash.
gonna shade the other area ever?
Okay, how do you
It's
think?
greater than.
The arrow would be
Right.
the amount.
So if it's y is greater than, you go above. If you get confused on what above is, it's just pretend this is like a roof. What's above the roof? That side.
Well, if it's a negative slope.
Well, it doesn't change much, but
Increase.
okay. Let's just jump in. We'll answer these as we go. We are on page 271. The first part is not graphing.
What happened to your book?
I can't remember if I.
What are we going to?
Hold on. Stare into the camera for a second.
Well, I don't know how that happened to your book.
Unless there's an extra one. Is there an extra book, Mr. Jordan?
Not in here. No.
No.
No, look at
It's either
No,
channel.
it's like a
1 through 8, 13 through 28 on page 271.
a
13 through what?
28. 1 through 8, 13 through 28.
I figured since it was over it, we skipped this.
Are they all graphed problems?
No, 1 through 8 is not graphing. Actually, 1 through 1 through 8 and 13 through 16 is not graphing. Okay, on number 1, state whether a solid or dashed line is used to graph the inequality. Would number 1 be a solid line or a dashed line?
Solid.
Solid. How did you know that? Because it's greater than or equals to. If that equal to line is underneath, that's going to be a solid line. So number 1 is solid. Is number 3 going to be solid or dashed? Dashed.
Can I say dotted?
I guess. Dashed line. Okay. Number 5, it says determine. Yeah.
Determine what?
Determine whether which ordered pairs are solutions to the given inequality. It could be all of them, it could be one of them, okay? So you have to check all of them, see if they work. So is 0, 0 a solution for number 5? If you plug in 0 for the y value and 0 for the x value, looks like this. Is that a true statement? What's 2 times 0 minus 9?
Negative.
Is 0 less than negative 9?
No.
No, so A is not a solution, so don't write A down, basically. For B, if I plug in 7 and 4, 4 is the x. What's 2 times 4 minus 9?
-1.
Is 7 less than negative 1?
No.
No.
Don't
So
write.
don't put B. Some of these have like 2 or 3 answers, by the way, so you can't just find one and then skip on. C, negative 13 less than 2 times negative 2 minus 9. What's 2 times negative 2
-4.
minus 9? Negative 13. Is negative 13 less than negative 13?
No.
No. If it was equals 2, it would have been yes, but if
So can we
It's not
just
less
put D then?
okay, if we plug in D, we get negative 5 less than 2 times 3 minus 9. 6 minus 9
-3.
is negative 5 less than negative 3.
Yes.
So D is the answer to number 5.
The only answer.
The only answer, yeah. Okay, I'll just tell you, 7's only going to have one answer too, but 6 and 8 have multiple answers.
Sorry, I
Uh, on 7, why don't you guys take a good guess of which one's the right one? Well, 0, 0 is easy to check, right? If you do 2 times 0 minus 5 times 0, what do you get?
0.
Is 0 greater than 1?
No.
No. So it's not K. So which other ones do you want me to try?
L.
L.
L. Okay, if I plug in 3, I get 2 times 3 minus 5 times 1.
1.
Is that greater than 1? 2 times 3 is 6. 6 minus 5
1.
is 1. Is
But
1
it's-
greater than 1?
No.
No,
No.
it's not L. If I plug in M, 2 times negative 2 minus 5 times negative 5, is that greater than 1?
No.
2 times negative 2 is negative 4. Negative 5 times negative 5 plus 25.
So yes.
Whoa.
Is that greater than 1?
Yes.
It is. So on 7 only has one answer, I'll just tell you that, so for time's sake. M is the only one that works on 7. Okay, we're skipping 9 through 12. 9 through 12 is kind of the same thing, really. Number 13. Darn it.
Is this on a graph?
No. Not graph. Okay, on 13, it says it's multiple, it's matching basically. It says y is greater than. If it's just greater than and not equals to, what kind of line should we have?
Dotted.
Dotted. If it's greater than, should it be shaded above or below?
Above.
Above. So which one is dotted and above?
B.
B. So 13 is B. 15 is y is less than or equal to. If it's less than, are we shading above or below?
Below.
Below.
And
If
it's
it's
solid.
equals to, it's solid. So which one is solid and below?
A.
A.
So if it's less than, it's below. If it's greater than, it's above.
Yeah.
One.
If it's y is greater than, it goes greater
We're
than.
on
Yeah, 17 is graphing. 17 is the weird one too. We're starting off with the weird one. Okay, does anybody recall what the line x equals -4 looks like? Lydia?
-4 up and down, -4.
Yeah, you go to -4 on the x-axis, and then it's gonna be vertical. Okay, if it's x is less than, am I gonna draw a solid or dashed line?
Dash.
Dash, because it's not equals to, so. Okay, now we didn't talk about this one in the warm-up. There really isn't an above and below on this line. There's not an up and a down, there's a left and a right. And it says x is less than -4.
So
Guess which side we're gonna shade?
left.
Left. All the x values less than -4 are to the left of -4. So this is the one case where there's not an up and a down, there's a left and a right. So you shade everything to the left of your line. So 17 and 18 are kind of the weird ones. I'm not going to draw 18, but do you guys remember how to draw the line y equals 5?
Y equals one. Solid.
Horizontal.
Yeah, you go up to 5 on the y-axis and draw a horizontal line. And it says y is greater than or equal to, so you would shade up on that one.
Why did
But-
you go to 5? When should we-
Didn't say 5?
Oh, I was 18. I'm sorry.
18. Okay, 19. Okay, 19, the rest of them, these are going to be kind of normal. The more common problems, like 19. Did I write that right? No, plus. Alright, so kind of pretend like it's a normal equation. Where do we start to draw at?
2.
Yeah, up to. Up to. Where do we go from there?
3 up.
3 up and over 1, or down 3 and back 1. Is this line going to be solid or dashed?
Down dash. Or dash.
Dashed. Okay, this says y is what? What's that called? Greater than. So I'm going to shade greater than goes greater than the line, above the line. Yeah, above. So all this stuff. Just kind of ignore the axes, you go right through them. Well, how do I graph that?
You solve it? Or not? Do you?
What do you mean solve it?
Like, subtract. Or, yeah. 5 times 2.
Yeah, you're pretty much right. You want to get y by itself so it looks like slope-intercept form. Once we get in slope-intercept form, then we know how to graph it, right? So subtract 2x. So I'm trying to get y by itself over here. So I get negative y on the left side, and the minus 2x and the plus 4, do those mix? No, they stay separate. What do I do with that
Divide by
negative?
-1.
Divide by -1. What happens on inequalities when you divide by negative?
The sign
They
flips.
just become,
Yeah. Yeah, those switch, but also the inequality switches. Do you guys remember that?
yeah.
When you have to divide or multiply by a negative thing?
Yeah.
So it becomes a greater than or equal to problem again. Okay, now that was the hard part. Where do I start on the graph at?
-4.
Down 4. Where do I go from there?
Up to over
over
one.
1.
Up to over 1.
It's maybe
The line is going to be solid. And where are we shading?
Above it.
Above.
Above. It's y is greater than again.
Why wouldn't you go up 4? It's plus 4, isn't it?
Minus 4. We had to divide by -1, which switched all our signs.
Oh.
Okay, I just screwed up my graphs there. Okay. Hopefully
You
this.
only have to make 3
one.
dots.
Oh, okay.
Huh?
You only have to make 3 dots.
Yeah, 3 dots is fine. Okay, 23, x plus y. It's another greater than problem. Do we have any less than problems?
So
25 is less than. Okay. X plus y is greater than -2. Okay,
What?
what do I do first?
Oh, it's.
you have to make it.
Get y by itself, right?
You get the center.
Minus the x. So you get y is greater than, I'm going to put minus x in front of the -2.
Oh.
Where do I start the graph?
Maybe
Down 2. Where do I go from there?
Up 1.
No.
down one.
So I go
Down 1.
down 1, right 1. Okay, you can't make them both negative. That would actually be like a positive. So down 1, right 1. Down 1, right 1. Remember, negative slopes should be falling, right?
Going to be dash,
Yeah, is it dash or solid?
dash. And it's going to be
Above it or
above.
You're above.
Yeah, y is greater than, so we're above again. We haven't done any less than yet.
Well, 17's a less than.
Yeah, but it was left and right. It was a weird one.
We did
True.
21 was the last.
It switched to greater than when we divided,
Wait, why did it switch to greater than?
because we divide by -1. Inequality switch. 25 is a less than. We got at least 4 minutes. Alright, 25, x plus 3y is less than or equal to 12. What do I do first?
You get
Make
rid of
the
the
X
x.
over.
You get the y by.
Get rid of the x over here. Minus x, minus x. So I get 3y. We're going to put minus x in front of positive 12, plus 12.
Divided by 3.
Divided by 3. Okay, I didn't switch the inequality because I divide by positive 3.
All right, Wesleyan Christian School Elementary. Today's total for the Bedlam Food Drive. OSU had 305. OU had 369. Don't forget, there's only one day left. Tomorrow at noon,
Wow.
we close
Who's
the
winning?
booster
Oh, yeah.
items
I was
for
shocked like with you.
for the Lighthouse and Boomer Sooner.
Yesterday she said go post. How dare she?
Because,
switch
oh,
sides.
she was.
She said Emerson.
Yesterday she said go post.
Well,
Yes, Yesterday she didn't say
Yesterday they were
anything.
Yes, but she's switching sides.
No, there's a
Because OU's
different
winning.
Shouldn't do that.
Anyway.
That was a different person. That was a different person.
Okay. There is no number right there, so that's like a 1 right there, right? So this is negative 1/3 x plus 4. Okay, where am I gonna start at? Positive 4. I got all my work all over the place. Where do I go from there? Down 1, right 3. Down 1, right 3. Is the
We
line?
can't go 3 on ours.
Oh, you can go backwards, man. Like that.
Solid.
Solid line. How about the shading? Right, y is less than sort of below.
Why is it always the majority of the graph?
Oh man.
Hold up. So which one's Nate? Is it? It's Nate. Okay.
Oh man. 27.
Just do tomorrow or is it today?
Tomorrow.
I didn't say.
It's always just the next day.
Wasn't last time, wasn't
Well, that was her assignment. It was a TV assignment.
Alright, 27 is pretty weird also. 28 is a little bit
Don't you
weird.
just divide by 3?
Okay, divide by 3.
So it's
So
you
you get y is less than 7/3. What is, you guys know what 7/3 is as a mixed number?
Now,
1 and 2/3.
Close. How many times is 3 going to 7?
2.
it? 2 and 1.
With the remainder of
2 and 1/3.
Okay, you guys, let's pause here. You guys remember how we graph like y equals 2?
Yeah.
Up to.
Like this, go up to 2 and like that. So y equals 2 and 1/3 would be up 2 and 1/3.
Why are we?
Right about that. Okay, is the line supposed to be solid or dashed?
Dash.
But which one?
Dashed.
Ah.
Probably should have changed colors. Blew it. Okay,
Dash.
says y is less than, so guess where we're going?
And then
Down. Wonder if there's a way to do this in style.
You know, I can't look at the evens.
There is no way.
Probably if you.
There is no way.
Wait. What's that do?
Miss Lynn does that.
Maybe you can get like shapes.
You can do like
somewhere.
stars. Yeah, you can do stars and stuff. We would probably know.
Leo.
Go big. Big blue.
Go big or go home.
Now let me stay blue.
Now you touch the screen. Wait.
Whoa.
Wait, right?
Wow. Mind blown. Wonder if there's
Are you? What are you doing?
a shading. You disapprove? Okay, on 20, on 28, I'm not doing it, but what should we do first?
Huh?
No.
What happened?
Divide by -1. When you divide by -1, the inequality switches. So it's actually x is greater than or equal to 2.
Where?
Number 28. So it's a lot like number 17, basically, because it just has an x.
So.
Okay, your turn.
Wait, so how,
Good luck.
so you just, on the x-axis, you just